or is 0.091, whatever it is, whichever is closest, we select a z value from here. So let me see what is the z value here. It's minus 1.28. So minus 1.28, which is this. So an alpha value of 10%, so the 10% significance level, this is the closest. So 0.1 is actually the 10% significance level. So a 10% significance level, the standard z value is minus 1.28. That is how we select. If it was like our confidence level, significance level was 5%, then we would have looked somewhere over here, this value being more closer to 5%, I guess. Then we say that based on the 5% significance level or 0.05 significance level, our standard z value is minus 1.61. So in this case, 10% significance level, our standard z value is minus 1.28. So can you see these slides now? Can you see the slides? Okay. So our computed value is minus 2.63, and from the standard normal graph, you don't see the slides? Okay, let me share them again. How about now? Can you see it now? Okay, thank you. So for this is our computed z value. This is based on the mean that we found from our data set we collected. This is the claim that we made divided by the standard error that we computed. The z value is minus 2.63. And then based on our significance level of 10%, the standard z value is minus 1.28. Now minus 2.63 that we computed is less than minus 1.28, which means this is our critical region. Here is minus 1.28, and the one that we computed is minus 2.63, which means it falls in this critical region, in this negative critical region. So we reject our null hypothesis in the favor of the alternative hypothesis. Our null hypothesis that the workforce average age is greater than 55. However, based on this test, we found that our null hypothesis is not correct. It's rejected in favor of the alternative hypothesis. So the decision based on this test is that the average workforce age is less than 55. So now you understand why we conduct the hypothesis test. Why? Because we make certain claim, and then we want to verify that claim. And then based on the calculations, based on the values that we computed, based on the standard values, we find out whether the claim that we made, is it correct or is it not. So understood? Is it clear to you so far? Any questions? Yes. Okay, thank you. So now this is one example. Now you see here, this is for the ease for your future use. And I found this table, and this was very helpful. This is very helpful from Shom series. I found this table, and it gives us the different values of the standard these are the standard z values for different significance levels. So 0.1 significance level, 0.05 significance level, 0.01 significance level. Now, when we say significance level 0.1, which means that 10%, we are allowing 10% error in our decision. We are 90% confidence about our claim. 0.05 means we are allowing 5% error in our hypothesis or in our decision, and we are 95% confident about our claim. And same here, it's 0.01, which means we are allowing only 1% error in our claim, and we are 99% confident about our claim. For one-tailed t-test, the standard z-values are this, and for two-tailed t-test, the standard z-values are these. So you can, rather than going to that big table, you can pick the values from here based on whether you are doing the one-tailed test or two-tailed test. So this is kind of a summary table for your convenience. Let's discuss another example. An article published recently indicated that the average weight of man in Karachi is 170 pounds. Now I changed the cities, etc. here. So this is what was published. It said that the average weight of men in Pakistan in Karachi is 170 pounds. To verify, now certain Weight Watchers company or certain food company, to verify this claim, what they did is they collected weight of 50 men, a sample of 50 men, and they found their weight. The mean weight was found to be 200 pounds with 35 pounds of standard deviation. So this claim was made somewhere else. To verify that, they collected this company collected the sample weight of 50 men, and they found the average weight of 200 pounds and the standard deviation of 35 pounds. Now the null hypothesis that this company makes, it says that the average weight of man is less than 170 pounds. Well, this is what we claim, that whatever published is, we do not necessarily agree with it. So our claim or our null hypothesis that company said is that the average weight of man is less than 170 pounds. So whenever we have a null hypothesis, we always have an alternative hypothesis, and the alternative hypothesis is just opposite of the null hypothesis, that the average weight of man in Karachi is greater than 170 pounds. Now again, so we compute the compute the values here, do the statistics. Standard error is standard deviation divided by under root of sample size, which came out to be 4.95, and then the z-value is 200, which is the mean, that sample mean. It came out from the sample that we collected. This is what we claimed. So 200 minus 170 divided by standard error, that gives 6.06. Now then we are saying that that company, whoever wanted to conduct the test, it says that they are 95% confident about their claim, which means the significance level is 5%. Now for a 5% significance level, and for a now see again, this is a one-tail t-test, because we are increasing the value here. We are definite, this is a definite increase in the value, so this is a one-tail test. So for a 5% significance level and for a one-tail t-test, the z-value is the positive z-value is 1.645. So z-value is 6.645. Are computed at 6.06. The standard is 1.645. Now since 6.06 is greater than 1.645, therefore the null hypothesis is rejected in favor of the alternate hypothesis. And how come? How this is possible? Let's go back to this graph and see the way we have this small critical region on the negative side. Since this is 0, this line is 0, this is a negative critical region. Likewise, for a one-tail test, we have a critical region over here on the positive side, and our standard z-value is 1.65, which means our computed value of 6 will fall somewhere over here because it's greater than 1.65. So since our computed z-value is greater than our standard z-value, it falls in this critical region. And when it falls in that critical region, then we reject the null hypothesis in favor of the alternative hypothesis. So the companies claim that the average weight of men in Karachi is less than 170 pounds is rejected in favor of the alternative hypothesis. Or we can also say that there is not enough evidence. We don't have enough sample, we don't have enough evidence to accept the null hypothesis or to claim that whatever statement we are making is correct. So we are rejecting the null hypothesis in favor of the alternative hypothesis. So is it clear so far? How do we do the one-tailed t-test? Everybody? And we'll do more examples for the two-tailed test. No, it's not clear. So what's your question? You want me to repeat this? Okay. Let's repeat the second example again. Now, let's say, for example, news is published in the news is published in the daily newspapers that the average number of crashes or average number of accidents that are reported is, let's say, 10 or let's say 5 accidents every day in Karachi. It's published somewhere. Now you want to, you being in an industry, or you are being in any like maybe the police force, maybe the people who are in national highways, or the government wants to see whether what they say, whatever is published, is it correct or not. So they make their own hypothesis. They say that the police say that our claim is that the total number of crashes that happen in Karachi every day is less than 5. Now, that is my hypothesis. And I want to check whether the claim that I have made, is it correct or not, or whether whatever I'm saying, is it really based on certain evidence or not. So to prove my claim, to prove my hypothesis, what the police department does, it collects the crash reports randomly from different police departments, and then they find out, let's say what I'm talking about as a fatal accident, like the accidents in which people die. So they go through all the crash reports and they find out a mean of the total fatalities which are caused due to the accident. And they find out that the total fatalities due to the accident is 3 per day, and there's a mean for crashes, and the standard deviation is 1. Let's say this is based on the data that they have collected. Now they will compute a z-value. They'll conduct a z-test to see whether the claim that they have made is correct or not, or should it be accepted or should it be rejected. So they compute this z-value. Now z-value is based on the equation here, this equation. You compute a z-value. So this x is the x that is based on the data, or this is the mean value based on the data that you collected. You collected to prove or reject your hypothesis, which is 3 based on the example we just discussed. This mu is the claim, or this mu is the mu of your null hypothesis. Then your null hypothesis is that the average fatalities due to the crashes in Karachi is less than 5. So it is that average. This is your claim. Mu is your claim, and x is based on your observation or the data that you just collected to reject or accept your claim. This value is the standard error. And standard error, how do you compute this standard error? There is the equation there which says the standard error is equal to standard deviation divided by underscore of the sample size. So you compute this, and then you compute a z-value. Now you select certain significance level. You select certain confidence level for your claim. Let's say you are 90% confidence about your level. 90% confidence about your claim, which means you are allowing 10% error in your claim, or you are allowing to have 10% error in your type 1 error or in your claim. So based on that